Welcome to this lecture on depletable resources. It's really straightforward. Uh, you have some concepts which are pretty straightforward. So this chapter presents the topic of resource scarcity within the general taxonomy of resources. So we will be looking at what we mean by resource taxonomy, and we will emphasize the concept of resource scarcity. Then we will also take a look at the implication of both efficient and profit maximization decision making. What do we mean by efficiency? We are looking at what is best for society, not just for a private firm. And when we look at profit maximizing decisions, we are looking at how the individual firms go about making decision on how to extract and use their resources. So let's take a look at the concept of resource taxonomy. Resource taxonomy is simply a classification system used to distinguish various categories of resources available. So here we will look at the first, second, and third one, current reserves. So whenever we talk of current reserves, we are looking at resources that can be extracted profitably at current prices. So for example, if the price is $60 and you can extract it at a cost less than 60, then it's profitable and that forms your current reserves. So you can make a profit now out of it. Potential reserves are resources potentially available. So it's available, however, here we say they depend on people's willingness to pay and technology. So the potential reserves can become current reserves if the willingness to pay of people rises, or if we have the right technology to extract it in such a way that it is profitable. It's however there, but it's not yet the current reserves. And then when you think of resource endowment, you are simply looking at, it represents the natural occurrence of resources in the earth. It has nothing to do with profitability. You are just looking at the natural resources available. Now, here we have lots of different things which are defined. I will not spend time here because the explanations are pretty straightforward. For example, identified resources, you are simply looking at the resources that have been located. There is a clear location, the quality of the resource is there, the quantity has been identified using geological techniques. Now, measured resources, we are looking at the quantity and quality estimates within a margin of error of less than 20%. So estimates have been made. Here they have been clearly identified, but here you are simply talking of estimates within a margin of error of less than 20%, and we still use geological techniques. Then indicated resources, and so on and so forth. So just take a look at it. The concepts are pretty straightforward. If anything is not clear, let me know and I'll be more than happy to clarify it. Now, if you take a look at this chart, when you go from left to right, it's going to show decreasing geological certainty. So geologically, we are very certain with what's here, and certainty decreases as you move on. Because here we are, it's measured, this is indicated, this is inferred. Just take a look more at what has been said here. Most of the concepts which are here, we bring it back there. And here we are looking at economic viability. It decreases when you go from top to bottom. For example, these ones are economically viable. These ones are not yet. Here it says sub-economic. So when we talk of economic viability, we simply mean profitability. So the cost is less than the price. So here are the reserves. Of course, we've mentioned the different types of reserves which are there. However, these ones are, you are looking at something that is economically viable. Now, let's take a look at the different types of resources. We have depletable, recyclable, and renewable. When we talk of depletable resource, we are looking at a resource that is not naturally replenished or replenished at such a low rate that it can be exhausted. If you think of the oil sands, it took millions of years to be there. However, within a few decades, you can exhaust it. Basically, the depletion rate is affected by demand. So when there's high demand, people use it a lot, and thus by the price elasticity of demand. What do we mean by price elasticity of demand? When you use the resource, prices normally start rising. Now, price elasticity measures the sensitivity of the demand to a change in price. So if prices are going up and people don't care and they keep buying the resource, then we are looking at an inelastic resource. But if prices start rising and quantity demanded drastically falls, then you are looking at a resource with high elasticity. So all of those things, they affect the rate of depletion of the resource. Now, talking about recyclable resource, we are looking at a resource that has some mass that can be recovered after use. Think of a resource like copper. Okay, copper is an example of a depletable, recyclable resource. So you can use it. It takes such a long time for it to be formed. However, you can recycle copper and use it again. Now, when we talk of renewable resource, this is one that is naturally replenished. Of course, you can mine it. You can use it at a rate that is faster than the rate at which it can be replenished. For example, fish. You can cause a collapse. You can cause collapse of a forest. However, we want to make sure, the resource can be replenished during our lifetime. That's really the main idea behind it. And now, based on the different taxonomy, the resources face different management problems. Here we see the management problem for a depletable resource is how to allocate dwindling stocks among generations. So you are asking, for example, that the oil sands, as you keep using it, it's going to run out because it takes millions of years to be formed. Now, how do you allocate the usage of that resource between now and future generations? That's the main idea behind it. So that's why we say among generations, why transitioning to a renewable alternative. Now, the next resource, here we are talking of the management problem for renewable resource is in maintaining an efficient and sustainable flow. So think of fisheries. You want it to be efficient and sustainable. You don't want to run the resource down by harvesting it in a way that is not sustainable. So these are the two main categories. Here we are not talking of the recyclable resource. We are just looking at the management problem of depletable and renewable resource. These are the main problems between those two. Now let's use the model. We will use this framework known as the two-period model. What do we mean by two-period? The two-period model uses now and the future. So we call now period 1 and the future is period 2. That's all. And it's all about how to use the resource. Should we use all of it now or should we keep it and use it in future? However, dynamic efficiency has to do with how to allocate that resource between now and the future. What quantity should be used now versus in future? That's really the idea behind it. How to use a certain amount and transition from a depletable resource to a renewable resource in future. That's what we are trying to do. Now let's take a look at the end period constant cost case. When we talk of constant cost, we are looking at the cost of extraction of the resource. We are simply saying that after it's really possible to have constant, let me rephrase it. So we are looking at a case where the extraction cost is constant. So here we say with constant marginal extraction cost. Now it's important to note that when we talk of marginal extraction cost, it is the cost of extracting an extra unit of the resource. So when it is constant, total marginal cost, or the sum of marginal extraction cost and marginal user cost, will rise over time. Marginal extraction cost, I have already said it is the cost of extracting an extra unit of the resource. Meanwhile, marginal user cost has to do with the opportunity cost of using that resource, or relative scarcity. Now let me take a simple example. If you have 10 oranges and you use one of them, you only have 9 left. And if you use one more, you only have 8 left. So as you keep using that resource, it becomes more and more scarce. In other words, the marginal user cost is rising. So even though the extraction cost in this scenario is constant, marginal user cost is making the total cost rise over time. So rising marginal user cost reflects increase in scarcity, because as you use, for every unit of the resource you extract, the resource becomes more and more scarce. So we are saying rising marginal user cost reflects increase in scarcity and the intertemporal opportunity cost of current consumption on future consumption. So when you consume one resource now, it means one resource less for future generations. So the challenge is, how do you organize, how do you spread it out across different generations? Let's take a look at this diagram. You can see A is looking at constant marginal extraction cost with no substitute resource. So if you keep extracting that resource, you will get to a point where you can no more extract it. Why can you no more extract it? Because you would have exhausted your current reserves. In other words, what is economically viable, you will get to a point where extracting any more of this resource is no more economically viable based on the technology you have. Now you can see here on this other side, on B, we are looking at the constant marginal extraction cost with no substitute. You will get to a point where you will have to stop because the market, people are no more willing to pay for it. Here you have the constant marginal extraction cost, and here the total marginal extraction cost is increasing. Why? Because of, as we mentioned here, increasing scarcity. So basically the marginal user cost is rising. So here you have the extraction cost plus the marginal user cost. When you add both of them, it's increasing over time. And you get to a point where the market is no more willing to pay. Here we have time 9. You get to that point where there is a total collapse because there is no transition. Here is the case where there is no substitute to that. And we will continue in the next video.